All right, Sayusa Learning Community, it's an absolute pleasure being with Mr. Martin Buck, our autos and mechanics teacher. Mr. Buck, will you tell us all about how long you've been an educator and in the field, and then also here at Sayusa School District?
Hi, I came from Ford Motor Company. I was an automatic transmission specialist at Ford Trucks in Portland. The Dealers Association asked me to start a regional program in the late 90s, and that's when I began my public education experience. I was training dealership technicians before that. I've taught at high schools and community colleges around Oregon, and I have worked for Snap-on for about 13 years. I'm part of the database system that creates the information systems you use from them. I came out here, it was a wonderful opportunity to get to live at the beach, and at my age that's a great thing to be able to get to live at the beach. And just the wonderful and supportive staff at this school and administration that is so committed to job training for students. And I'm really a big fan of theirs, and they have really done a lot. We're in the middle of a process of completely renovating the automotive program, and in a year or two you're going to see some pretty big changes in how we do automotive training. We're not just trying to teach kids about how cars work, we're trying to teach them what it takes to function in a job in the automotive industry. And fixing the cars is just a very small part of that larger industry. So this is a great door in.
It's fabulous. Will you list all the classes that you do teach, just for students watching who are interested in taking classes with you when they get to high school?
Yeah, our introductory class is a single semester, intro to automotive, or intro to mechanics, I should say. And then when you have done that, then we have a full year course, and that's a single period class, and that is Auto 2. And then if you've done that, then you can do automotive service, which is 2 periods for a full year. And if you've done that, let's say your freshman, sophomore, and junior year, you can come back and do it again, automotive, for 2 periods for a full year.
Okay. What would you say to students who are like, I want to be Mr. Buck when I'm older? Like, what is the schooling required and the career path to get to where you are now?
Okay. I hear a lot of people say, that trade professions are, they're, for people who don't want to go to college.
That's not true.
And it's really not the case. What it is it's an on-site and online, usually, training program that takes 4 to 5 years. They call it the journeyman system. It's been around forever. It's a different kind of college, but it's still that kind of education. If you want to be a plumber or an electrician, air conditioning technicians, things like that. Same thing with welders and such. They have their own journeyman programs.
Okay.
And you have to know things. You have to know about blueprints, and you have to know about codes and
Super
materials,
technical.
and it's very, very technical.
Super technical.
If you want a low-paying job, yeah, you can usually function at the lowest levels for pretty low pay. But if you want to move up the ranks and make any real money, it usually takes significant education.
Yeah. All right. Any final closing comments for our viewing audience?
Yeah, come on down, check it out, audit it, see what you think. A lot of times careers aren't what you think they are. Go down and sit in with with Kyle and Cuisine. See whether you think you'd like to be a cook. Go down and sit in with Josh now at welding. See whether you think a metals career is something you'd like. There's just a lot of things out there. You may want information systems, and you may want to be a librarian.
You may.
Yeah, there's just most careers aren't what you think they are.
Right.
And so just take a good look at them before you invest too much.
Well, thank you so much for inviting me into your classes. And students, you're going to see some clips from a couple of his different classes. Enjoy. Bye. All right, so we're in Mr. Buck's class. Do you want to introduce yourself and then just share what you're doing and then tell us how you are enjoying his class so far?
Yeah, I'm Taylor Hatfield, and right now we are doing a tire rotation on this Chevy. And I enjoy this class because it makes me explore my options in my future self. Like, I could take mechanic classes out in other colleges, and it just gives me more of a reason to be here, and it makes me enjoy myself more because I love cars.
Okay, yeah, and it's like super practical. Whose tires are we rotating? Like, where do you get the cars from? Is it students, staff members?
I have no clue. I mean, students can come in and have their cars get lifted up. Like, that's one of Mr. Buck's cars over there.
Okay. So we get cars from somewhere.
Yeah.
Okay. And then, what year are you? Are you a freshman, sophomore,
I'm
junior,
a
senior?
junior.
Okay, and how many years have you taken autos and mechanics? Do you have the option of taking it multiple?
This is my intro class, and this is my second year coming to Siuslaw. Last year I did medals with Mr. Tregoning, and it was a really good experience.
Okay. All right, thank you.
Voltage testing, we did amperage.
Okay,
we
current
did-
testing, amperage,
We did resistance testing.
and then we've done resistance, we did the
diode test.
and then, and as part of resistance, we did what?
Diodes, or conductivity test,
What?
conductivity. Or
Very close, you almost had it.
the one with the Wi-Fi symbol.
10 or below ohms
Continuity.
continuity, thank you,
Damn it.
continuity.
Uh-huh.
Okay, so now we're up
I
to,
wasn't joining.
or no, we did energy when disconnected from the charging circuit,
This is number
short-term
6.
energy storage. And as you can see, there's a lot of different kinds here. You don't see very many capacitors anymore, almost anywhere, because everything is solid state now, everything's computer circuitry. What is a distributor?
No, my
That's a
grades
capacitor, a wet capacitor. And these kinds right here, you'll run into, and they're inside electric guitars. They're what creates the tone, because they smooth out the signal. Creates a tone change.
Mr. Buck.
It does is it's an overflow. It's like the Nile Delta. You know, the river is about what? Half a mile wide, quarter of a mile wide, until spring comes and all this water comes down at once and it overflows the banks. And then as the water starts flowing less and less and less, that water migrates back into the river. That's what a capacitor does in an electric circuit. A surge of electricity will go out into the capacitor, and as the pressure drops, that current will go back in. Remember what we said of how much electricity is an amp?
And a singular amp.
1 amp. How do we measure an amp? Terminal ground.
Whoa.
And we're gonna move the rotary dial to that funny looking arrow going up against the wall. Looks like a little arrow that bent ground. What is?
Fahrenheit.
Nope. Nope.
I
A-R-A-D.
was so close.
A measurement of, it's for Michael Faraday, called the farad. Millionth of a second, 1 nanosecond, it'll go through 6 inches of wire. Think about if you were trying to synchronize 2 things across the world, 2 electrical circuits, okay? It would begin to matter whether they synchronize correctly, especially when you talk about computers, clock speeds in computers and stuff. Car misfiring, you had a 1965 Mustang, and it was misfiring and misfiring and misfiring, and you found out that the points were burnt. This would be the exact test you would do. You would disconnect the little lead from that little can off of the points, and you'd hook the meter up, you put it in capacitance, and make sure it had the proper farad value, okay? And if it didn't, what would you do, Terry? If it didn't have the proper capacitance, what would
Oh,
you do?
no, that's a good question.
Can you repair that? Can you repair one of those components? No, you can't. You just replace it. Okay?
What about it?
What is it?
Oh, it's the. Shoot, how do you explain it? It's the. Is it waves?
Yes.
So it's like how many waves are per second?
Perfect.
Are we able to
Perfect.
disconnect
That
this?
is frequency, is how many waves per interval. That's a frequency, percent duty cycle. So it's the amount of on and off time within frequency. Here's an example here. So we're on a short amount of time, we're off a long time. On a short amount of time, off a long short of time. This, what they used to do is they used to use a resistor and they would drop the voltage to a light, and that's how you made the light dimmer and dimmer and dimmer. Now what they do is they send you a full voltage signal, but they turn it on and off at different rates. And what ends up at the other end is a dimmer light. It just isn't on as often, and your eye can't see it, just like they can't, most people can't see the 60 cycles per second up here in these lights. Some people can, I can't. Okay, we are gonna put the battery in. Remember what we said? Don't push it up, squeeze it on. If you push it up against it, it's gonna end up breaking off. So squeeze that battery on.
Are they
Is
supposed
it
to
normal for this to be so like bent already?
Connect the black test loop to terminal number 6 on the ground, and turn the simulator on. Little button on the top, hold it down until you see the light.
You said J4 or J2?
Now dial B, that center dial, clockwise, and watch the changing frequency value. So turn it halfway. Misha, what does yours say at half?
Like 445, so.
400, something called a thermistor. A thermistor is the reverse of normal physics.
I did
Ah,
it first.
In normal physics, any material from rock down to water to whatever it is
Terry.
behaves exactly the same way. The higher the temperature, the more resistance there is to flow of current. That's why you've heard of superconductors. Most superconductors have to be super cold before they'll flow. We're gonna put them into the 2 center ones, and we're gonna put the black in the common ground. We're gonna put the red one into that one right there, okay?
We turn this thing
And
on.
that is the micro milli amp.
Why do these
temperature
leads seem so?
flux.
We're done with this?
Yeah, just set that aside for now.
How expensive are
So you
these?
can test this just by
Oh.
blowing on it. You'll see the.
It's 78 degrees.
All right, there we go. Okay, we are now checking out one of the simulators in the auto shop. We're back with Taylor, and if I do a quick pan, we are up top on like a little balcony area. So Taylor, what are we looking at? What is this thing?
We're on the simulator for the students. It's for everyone. Anyone can play it on their free time as long as they ask permission first. The basic use of it is to teach students and people who are younger, our younger generation, how to drive manual, because most people don't know how to drive manual at this age.
Okay, so you have to, this is a manual setup here. I know how to drive manual, but I'm not very good. So I could probably get better just by playing this thing right here. So why don't you show us how it works? This is super rad. All right, and anyone can use this simulator. I bet we have students who don't even know this exists in the auto shop at Sayusa High School.
What are we doing?
Okay. And then Taylor, for our friends that don't know how to drive a manual, is it a transmission, manual transmission?
Yes, it's a manual transmission. It's a type of manual that they don't normally make anymore without flash sticks.
Okay.
And
So you're shifting on the steering wheel there, or is it
Well,
over off to the right? Okay, so you have your typical shift, gear shift,
Yeah.
and then you have, what is the pedal called on the left?
you have your clutch.
Clutch.
It's called a clutch,
Clutch, gear shift.
which is to engage the process of making the transmission free to shift into a different gear.
All right. Well, thank you so much, Taylor. I'm going to
Yeah.
swing around here real quick. We also have up in this balcony, there is a flight simulator that will be up and running soon. We have a couple other gizmos and gadgets. And then Mr. Buck is also a musician. Taylor, you're a musician, you play the piano.
Yeah.
Mr. Buck plays the guitar. So just like we have a music makerspace station in the library, Mr. Buck has open access to instruments in the auto shop as well. How cool is that?
That's really cool, and I think it's a good experience for students to be able to learn instruments and
Yeah.
how to fly.
Thank you.